Yeah, I'd like to just talk about what we do here at ScannerMAX and some of the products that we make and some of the challenges that we face. Pangolin Laser Systems has been in business for 35 years. We are the world leader in software and related control hardware that's used to produce laser show performances. These are the things that you see at all the concerts around the world, all the nightclubs and amusement parks, and even movie special effects, Super Bowl halftime show, and even the Windows 10 backdrop on almost every Windows 10 system. It looks like 4 squares with light coming through it. That was done not only using a laser, but using lasers that we sold, using our software to produce that. So that's what we're best known for. In 2012, we got into the business of making laser scanners, primarily for laser display, but what we found was that those same types of laser scanners could be used in many other applications. For example, 3D printing, self-driving cars, scanning microscopes, and many other things using the same types of scanners or very similar scanners. So since then, since 2012, we have developed a whole line of scanners that serve a lot of different apertures, and that can be seen here on this table. And what's interesting is that we have one scanner, which was kind of our first scanner. It's called the Compact 506. The reason why we call it that is because it's so compact, it's very small. This is the tip of my finger, this is the entire scanner, and everything inside it is smaller than that. So it's very compact, and yet still very powerful and versatile. So this one scanner is capable of projecting not only 3mm beams, but really we put up to 20mm mirrors on this little scanner, which is unprecedented to use this wide variety of mirror sizes on one little teeny tiny motor like this. So over here you can see kind of the array of products. You can go ahead and kind of pan through this, Jordan. We start over here at with these small mirrors here at 3mm size, and then work up to 4mm, and looks like this is also 4mm and 5mm and 6mm here, and 8mm and 10mm, and this is here is I think 16mm. And again, it's all the same scanner. On all these products, it's just a different mirror on that same scanner. No changes inside the scanner. We also have a variety of higher performance products, because this, in order to get the kind of the versatility, there's always trade-offs. You know, one of my favorite economists, Thomas Sowell, said there's no perfect way to do any single thing. There's only trade-offs between doing things. There are no solutions, only trade-offs. That's what he said. So the trade-off with this one is versatility, and so in order to get this versatility, it means it does a bunch of things. It doesn't do any one thing perfectly, but it does a bunch of things, and it does it at a very compact size and very low cost. This weighs only 12 grams. So for more specialized apertures, we have a higher performance product line that we call Saturn. And we have this in Saturn 1, which primarily 3mm and smaller. We have Saturn 5, which typically is in the 5 and 6mm. We have a Saturn 9, which typically 8 and 10mm, and we have some other things in developments like that. But so this one here is a Saturn 5 scanner with a 5mm mirror, and like I say, we have some other ones too. We also produce a specialized motor. This is a continuous rotation motor. Galvanometer scanners, what they do is they move only over a limited range of angles. This is actually a Saturn 9 in my hand. Forgot I had this. So typically, galvanometer scanners move only a limited rotation. So it's considered to be a limited rotation motor, a limited rotation rotary actuator with a very precise position sensor on the back. The precision of the position sensor gives you precision in the single-digit microradians in terms of the position, so super high resolution and super high precision. But typically, the trade-off that has been made to make a motor go very quickly and very precisely is that it does this only over a restricted range of angles. So that was the trade-off that was made for laser scanners. We took the kind of the philosophies used in laser scanners, and we made a continuous rotation motor. So in my hand here, I have a motor that's capable of going round and round, and on the back there is a very similar position sensor to what we use in our laser scanners, but this position sensor